Hi, Mark Granis here with Lecture 6.3 on equivalent propositions. This corresponds to Section 6.3 of our text, The Reasonable Person, and it will wrap up Chapter 6 for us. And in some ways, we're coming full circle because we're going to end with equivalent propositions, which really is the first thing that we learned when we started Chapter 6. We took a little detour after we learned about the general equivalent propositions and went and did opposite propositions for a while, but now we're back to handle the last three little pieces of what we're going to learn here in Chapter 6. We'll begin, as usual, with a little bit of a recap. We'll recap what we've learned about opposite propositions and about the square of opposition into which they all fit, and then we'll turn to equivalent propositions. Similar, but different. And there are three different kinds of equivalent propositions that we'll learn about in this chapter: conversion, obversion, and contraposition. I'll tell you what you need to know about all of those, and then we'll end by summarizing what we've learned about these basic categorical propositions in Chapter 6 and all the many things that we now are able to figure out just from knowing part of the truth. So let's get going with the recap. First, we learned that opposite propositions are any two propositions that respectively affirm and deny the same predicate of the same subject. So we have to have the same predicate and the same subject. If we don't have that, then we haven't got opposite propositions. But assuming we have the same predicate and the same subject, if they respectively affirm and deny, then one of them will affirm and the other one will deny. That is, one will be affirmative and the other one will be negative. And that means that they will differ in quality. All of the opposite propositions differ in quality. But there are three different kinds depending on how they handle the issue of quantity. If two propositions differ in both quantity and quality, then they're the contradictory propositions, or contradictories. That's the A and O pair and the E and I pair. Those differ in both quantity and quality. That's why they form that great big X in the middle of the square of opposition. But if the two propositions differ only in quality, that is, one on the left and one on the right, then you've got two choices. Either they're contrary propositions, or contraries, if they're in the top row, because that means they're both universal. That's A and E. Or they could be subcontrary propositions or subcontraries if they're in the bottom row, because that's the row for propositions that are both particular. That's I and O. How does that look on the square? It looks like this. We have the contraries across the top between A and E. We have the subcontraries across the bottom. The subcontraries below the contraries. Get it? That's between I and O. We have the contradictories forming that great big X in the middle of the square, and then we have the subalternates, which are not really opposites, but we love them anyway. They're on the sides of our square, between A and I on the one side and between E and O on the other. With our square of opposition, then, we can tell the truth value of many other statements on the square if we know the truth value of one. So, for example, we see here that between A and E, we have an arrow, two arrows, one of them going from left to right, and it points from T to F. And then there's an arrow right below that that goes from E to A, also pointing from T to F. So whichever side you start at between the A and the E, you're going to go from T to F. And the arrowhead only points in one direction. It only points from T to F, because only if you have a true statement, a true contrary, A or E, then you know that the other one must be false. But a false contrary doesn't tell you anything. That's why there's no arrow up top that goes from F to T. The arrows for the contraries only go from T to F. On the other hand, if you look down at the bottom, those are the subcontraries, the I and the O, and there the arrow goes from F to T in both directions. Whether you start at the I side or the O side, the arrow only goes from F to T, because a false subcontrary tells you that the other subcontrary must be true, but a true subcontrary doesn't tell you anything. Now, with the contradictories in the middle, we have double-headed arrows. They point from T to F and from F to T, and the arrowhead goes in both directions. That's because with A and O, or with E and I, if you know one is true, you know the other is false. And if you know one is false, you know the other is true. you will always have opposite truth values for the contradictories in the middle. And then we have the subalternates on the side. They're the tricky ones. They're the ones where the arrow goes from T to T, but again with the arrowhead only in one direction, or from F to F with the arrowhead in the other direction. Because we know that if all men are mortal, then some men are mortal. That is, a true A means that we have to have a true I. But we also know that if it's false that some fish live in trees, the I statement, then it must be false that all fish live in trees. So a false subalternate at the particular end means the other subalternate must be false. And a true subalternate at the universal end means that the particular subalternate must be true. So a little bit different for those. That sums up what we know about opposites. Contradictories always contradict. True contraries falsify. False subcontraries verify. And for the subalternates, they descend with truth and rise with falsity. All right, well, now let's move on to equivalent propositions. Equivalent propositions, as we learned at the beginning of the chapter, are propositions that differ in form but not in matter, and which must always carry the same truth value. What do we mean by differ in form but not in matter? Well, to not differ in matter means they're about the same things. So, if this is about monkeys and whether they're trained, if the original is about monkeys and training, then the equivalent proposition is also going to be about monkeys and training. The key really to this definition is that they must always carry the same truth value. They must carry the same truth value. It's not enough if they might carry the same truth value. It's not enough if you've looked at it and verified empirically they just happen to have the same truth value. That's not what we're talking about. We're talking about statements that are related in form in such a way that we know, if we know that one of them is true, the other one is true, and if we know that one of them is false, the other one must be false. It has to be such that the form guarantees the equivalent of the statements. There are two other aspects of equivalent propositions that make them a little bit different from opposites, and they have to do with the way we treat the subject and the predicate. So first of all, the subject and the predicate may switch places. With opposite propositions, we always said you had to have the same subject and the same predicate. That's not quite what we're saying here. What we're saying here is that you have to be dealing with the same matter. That means that the subject and predicate are going to be, the same matter, but they might switch places, or you might negate one or both of them. So instead of dealing with monkeys and trained, you might be dealing with monkeys and untrained, or non-monkeys and trained, or non-monkeys and untrained. So there might be a little bit of modification to the subject and the predicate, either by swapping their places or by negating one or both of them. But we're still going to be dealing with the same overall matter. We're not switching from crooks to saints, or from lawyers to senators, or anything like that. There are 3 equivalent propositions, and we're going to learn all of them in the next 10 minutes or so. There are really only 2 things to keep straight about each one. When can you do it, and how do you do it? And in each case, I would say one of those is incredibly easy, and the other one is only a little bit harder, a little bit tricky, but not terribly tricky. So I think that helps. Think about when and how in each of these cases, and just know that one of them is always incredibly easy. Okay? Let's get on with it. The first statement is conversion. Conversion is the first operation of equivalence that we want to talk about. And we can define the converse as the equivalent proposition that we form when we reverse the subject and the predicate of our original proposition without making any other change. Right? So when people say conversely, this is where that usage comes from. This is what they're talking about. If we have an original statement like no hobbits are wizards, well, our subject is hobbits, our predicate is wizards, we're simply going to reverse them. No hobbits are wizards has a converse of no wizards are hobbits. What if we have some hobbits are ring bearers? Well, we're going to reverse those two. We're going to get some ring bearers are hobbits. How about some rings are magic? Well, now this is our opportunity to see why we added a few sections ago, back in chapter 5. Why did I teach you to start adding TWI? when you're translating, when you have an adjective like magic. It's because of this. When we want to swap these two, we can't say some magic are rings, but we can say some of that which is magic are rings, right? This is why we want to nounify everything by adding that TW or that TWI like we learned back in chapter 5. What about all rings are circles? Well, this one actually has no converse. And the reason it has no converse, at least no full converse, is because of the slightly more tricky thing about conversion, which is the when question. Full conversion is only possible with E and I propositions. All rings are circles, being an A proposition, means you can't do a full conversion. You can only do it with E and I. Now, we might pause here and say, well, why can you only do conversion with E and I? And it's an interesting opportunity to bring back in our earlier discussion of distribution. Recall that in the E proposition, the subject is distributed because it is universal, and the predicate is distributed because it's negative. In the I proposition, the subject is undistributed because it's particular, and the predicate is undistributed because it is affirmative. So in both the E and the I propositions, the subject and predicate have the same distribution. And therefore, when you swap them, you're not suddenly trying to address the entire extension of something that was only partly addressed in the original proposition. So that's the short version of why full conversion is only possible with E and I. It's only possible with the two statements that have the same distribution for their subject and for their predicate. Nonetheless, we can partially convert an A proposition into an I proposition. And the reason that we can do this is because of our friend, the subaltern. We can say that if all rings are circles, then we certainly know that some rings are circles. And if some rings are circles, the I proposition, then we know that some circles are rings. Right? So this is called a partial conversion. You can't do full conversion. All of Elvis Presley is dead, but only some of the class of dead people is Elvis Presley. But you can partially convert the A proposition. All of Elvis Presley is dead, and that means some dead people are Elvis Presley. Okay? So that is conversion in a nutshell. Here's the second type of equivalent proposition. It's obversion, and the obverse is the equivalent proposition that we form by changing the quality of our original proposition and negating the predicate. Now that's a little more complicated than conversion, and in fact, that's the hardest thing about obversion. The hard question with obversion is not when, it's how. And there are two steps. You change the quality, and then you negate the predicate. So for example, all Beatles are Britons. That's an A proposition. If we want to change the quality, we have to make it an E. That'll be no Beatles are Britons. But then we're not done there. We can't stop there. That's not equivalent. We have to change the quality and then negate the predicate. So we get no Beatles are non-Britons. That is the obverse of that A proposition. What about no Rolling Stones are moss gatherers? Well, we change the quality. That makes it all Rolling Stones are moss gatherers. But then we have to negate the predicate. All Rolling Stones are non-moss gatherers. How about some snarks are boojums? Change the quality. That makes some snarks are not boojums. We go to the O proposition. And then we have to negate the predicate. So some snarks are not non-boojums. Double negative? Well, yeah, we'll get to that in a minute. How about some whangdoodles are not whifflebirds? Okay, change the quality. That makes from R not, we go to R. We go from O to I. So some whangdoodles are whifflebirds. And then we have to negate the predicate. Some whangdoodles are non-whifflebirds. Not much of a change there. The I and the O, not a huge deal on obversion. It's more of a big deal for the A and the E. So what's the easy part about obversion? Well, it's this, that unlike conversion, obversion is always possible. You can always obvert. So two things to know, when and how. When, always with obversion. How? Two steps. You change the quality and you negate the predicate. Now, you are going to pile up some negatives here, and how you deal with them matters. When you negate the predicate, it is best to use things that attach to the predicate, like non with a hyphen, or un prefixes. When you negate the predicate that way, the negativity on the predicate will stay with the predicate. Save not for the copula, because I've seen it many times. If you put a not next to the predicate, then when you start doing some of these multi-step operations, you will forget whether the not is supposed to go with the copula or whether the not is supposed to go with the predicate. And it really does matter, because especially with some of these operations that are not available for all four of the propositions, you will get the question wrong. So don't do that. Use non or un when you're negating the predicate. Save the not for the copula. You should also feel free to eliminate double negatives if you want to, or not. It's perfectly fine to leave the double negatives. In fact, often if you do eliminate the double negatives, you'll be sort of defeating the purpose, right? You'll be, what is the purpose? Well, the purpose here is to sort of look at the mirror image of the truth. Turn the cereal box upside down and shake it to see if there's any more left. The negativity, the looking at the mirror image is the secret sauce here. It's what you're trying to do when you work with equivalent propositions. And so if you do too much of this streamlining and simplifying and eliminating the double negatives, you lose some, or you may lose in some cases, some of the benefits. So certainly allowed, as long as you're working, eliminate two at a time, never eliminate an odd number of negatives. But you're certainly allowed to do that, and it doesn't change the equivalence. It just might diminish the usefulness of what you're doing. All right, let's look at the third type of equivalence. It's contraposition, and we define the contrapositive as the equivalent proposition that we form by reversing the subject and predicate of our original proposition and negating them both. Now that's a little bit different than the definition in the book, and that's because it's a shortcut. The long way for contraposition is you first obvert, and then you convert, and then you obvert again. And because that's the long way, contraposition is only possible with A and O propositions. Why? It's because the middle step is conversion. And if you don't start with either an A or an O proposition when you obvert in the first step, then you won't have either an E or an I proposition when you convert in the second step. And as we know, conversion is only available for E and I. So you can only do this with A and O propositions. That's all you can do. But as long as you remember that that is true, then you can use this shortcut, reversing the subject and predicate of the original proposition and then negating them both. It's a much shorter way of doing it, as long as you remember that this only works with A and O propositions. So the contrapositive of all ghosts are ghouls. Let's reverse the subject and predicate. That would give us all ghouls are ghosts, and then negate them both. All non-ghouls are non-ghosts. Some snarks are not boojums. That's an O proposition, so we can do a contraposition there. And we would first reverse the subject and predicate. Some boojums are not snarks. And then we would negate them both. Some non-boojums are not non-snarks. What about some snarks are boojums? Trick question. You can't do a contrapositive of that statement because it's an I statement. And even though it would be easy to follow the instructions above with this shortcut, if we did it the long way with the obversion, then the conversion, and the obversion again, this would never work. So you can't start with an I statement like this. This has no contrapositive. Similarly, with no heffalumps or woozles, there's no contrapositive of that because it is an E proposition. Could we do a partial contraposition using a partial conversion? Yeah, but wow, that's down in the weeds. We're not going to cover that here. Okay, so we have the same rules on dealing with negatives here that we saw with obversion earlier. You really want to use non or un or something like that when you're negating the predicate, something that sticks to the predicate, and save not when you are working with the copula. Let's summarize all this and all the things that we've learned out, right? So the main point of opposites and equivalents was to extend what we know. If you now start with any of the four basic categorical propositions, there's a lot that you can tell from any one of these. If you've got an A, an E, an I, or an O, you should now be able to first identify the form of that proposition. That's pretty easy. Is it an A, an E, an I, or an O? You got to know that QSCP formula for each of those. And then you can identify the subject and the predicate, do any translation if you need to. You can identify the contradictory and the subalternate, because absolutely every single categorical proposition, A, E, I, or O, will have a contradictory and a subalternate. In addition, it will have one of the following. It'll either have a contrary if it's in the universal row, or it will have a subcontrary if it's in the particular row. You can also know what the truth value of the original proposition tells you about the truth values of all of the opposites. Sometimes it'll tell you a lot, sometimes it will tell you less, but it will always tell you something because, among other things, contradictories always contradict. Then, on the equivalent side, you'll be able to identify the converse or the partial converse, if there is one. You'll be able to identify the obverse, and you'll be able to identify the contrapositive, if there is one. All of these are ways to extend what you know, and really, that's an awful lot of knowledge to get out of A, E, I, or O. A proposition that might be as few as 4 words, and look how much truth value you can pull out of it. That's equivalent propositions, and that wraps up Chapter 6. I'll be back to start Chapter 7 next time.